Okay, this is how it works today. So we start with a general presentation of our master's degree. I am doing that for those who don't know me, probably everybody, but I'm Lapo Casetti. Then Michele Genolfi will present will briefly present the 6 curricula of our master's degree. We'll have after that a short question and answer session. If there are some general questions from you, maybe from someone from online. Then we have our break with coffee, snacks, beers, pastries, whatever. And at the same time, we start the second part of today, which is given by 6 separate meetings of the 6 different curricula, in which you can interact with professors, with researchers, with graduate students, with postdocs, and whichever, from the various areas of our studies, and you can meet them. We will tell you at the end which curricula correspond to which number, okay? And there are also some info points outside, one from the School of Science, one from the library, and one from for the Erasmus project that will be hosted by Professor Piazza, that is here, and then we'll move. Okay, so I'm sorry for any online guest who could not take part in the second part of the meeting, but I mean, you can contact people for that. So these are the contacts. So that one is the web page of our master's course. And I want to stress that from next coming year, only the English pages will be updated. Clearly, the Italian pages will remain active for all the people who enrolled in the course in the previous years, but they will stay at the content of today. While maybe we'll correct any mistakes, but there will be no new things. All the new things will be in the English pages. Okay. Oh, this is a list of people you can contact for your questions. So the president, Professor Vitaliano Ciulli, was here, and we are 2 deputies to orientation, me and Michele. These 3 people are the person you can interact with for the general questions. Okay, then there are some special issues. Professor Francesco Piazza for Erasmus, I already told you. We have a deputy for the inclusion, Professor Lusso. She's not here today because she's teaching. And then we have a deputy to the future, so to job placement. It is Professor Nicola Poli. I don't know if okay, he's there in the end. Okay, great. So the course is made up of 120 CFU. For the people not from Italy, I just remind that CFU is the Italian name of what in Europe is called ECTS. Is exactly the same thing. And so these 120 CFU are made of 48 CFU of core courses. Then there are some related supplementary courses for 18 CFUs. Then there are elective courses for 12 CFUs. The rest is made of the stage and internship thesis 6, and then the master thesis, which counts for 36 CFU. Actually, this is split in 2 things. And we have 30 CFUs for the actual research work, and then 6 for the part of writing and defending your work. Okay, so for the final exam. That's the point. The reason for dividing them is that maybe you can do, for instance, so the research work abroad or in Erasmus, and then doing the rest when you come back. Okay, so this is typically the master thesis contains original research, but is not compulsory, but is the usual way. Our course is organized into 6 different curricula. Here they are shown in rigorous alphabetical order. And as you can see, they cover all the areas of modern research in physics. So everybody could find something, okay? When you enroll for the master's degree, you have to choose one of these. Then some of these curricula are organized, are more structured, and are organized in study paths. There are some up to 3 paths, actually. No, maybe applied have even more than 3, remember. So there are some curricula made of different paths, while there are other curricula which are a single path curriculum. So what do you have to do to organize your studies? You have to build a study plan. This works this way. First, as I told you, choose one of the 6 curricula. Then at a certain point, you will be presented with a choice for the core courses. Typically, there will be a certain number that you have to take, and then you will be able to choose from other possibilities. And when you do this choice, then you will be able to choose within a huge list of possible related courses. And then in the end, you'll have also some elective courses, which essentially you can take whatever you like at that point. Okay, this typically, we expect that this standard situation will cover the needs of almost everybody. There may be situations in which this standard way is not possible, and you need to propose a personal plan, a personal study plan. The typical situation is Erasmus. Okay? If you take a semester or more in Erasmus, it will be not possible to use that procedure because we can't load all the courses of the European universities in our system. So you have to, and then you will prepare your plan with Professor Piazza that will explain you how to do that. Okay, this is a typical situation in which you can't follow the standard procedure. For Erasmus, this is you have to contact Professor Piazza, and you know he's. Yes, this would be okay. Yes. So when you say at the end, remember this. Great. Okay, so how does it work in practice? There is a window that typically is between October and November. The dates are published every year from the school, when you can submit your study plan. If, as it will be for almost everyone, that you follow the standard procedure, you just do it online, and in the end, your study plan is approved, but for a consistency check, just to be sure that you didn't make any mistakes or things like that. Instead, if you have to present a personal plan, this has to be discussed and is not maybe approved or not. And so, in order to ease the procedure, it's much better that, let's say, you have to, if you want to present a personal study plan, you have to contact the president, or maybe the orientation deputies, us, or if it's related to Erasmus, you discuss it with Professor Piazza. But before submitting a personal plan, please discuss it before. Otherwise, you will lose time. Okay. This is the idea. Change your mind, don't worry. You can change the study plan. It's not something that you sign with your blood. Okay, so maybe you start thinking that you want to choose those exams, and then you say, no, I want to change a couple of exams. No problem. There is a window in which you can change your in which you can change your study plan. This is typically in April, or there is also a fast-track change procedure in case you have to change it close to your final exam. Please use the fast-track procedure, which is a bit more complicated, only in case of real need, and not just to... This, sorry if it is a bit covered here, but when I try to hide this, everything explodes. I don't know why. There is the link for the study plans that you can find, okay? And we start September 22nd this year, and we have the usual organization in semesters. Second semester starts end of February, as usual. In the website, we'll find all the details, the holidays, the breaks, and whatever. I don't want to bore you about this. The big news, and the reason why I'm talking to you in English, is that from next year, all classes will be taught in English, nearly all. Okay, why nearly? There are some exceptions. First exception is this one. We have 16 courses of the master that are prepared especially as elective courses for the bachelor degree, laurea triennale. Okay, these are courses that are naturally part of the master degree, of some curricula of the master degree, but have characteristics that make that particularly well suited to be chosen at the end of the third year. Okay, so I don't want to discuss all of them, but you see the teachers, if you have questions, you can contact them. Okay? So these courses, since they are mainly prepared to be taken at the bachelor, will remain in Italian. So these classes will be taught in Italian. And there is another, so not only these ones, but also the course of Didattica della Fisica, that means teaching physics. This is because this course deals with teaching physics in Italian secondary schools, and so the language is one important part of this. It would be not very reasonable to teach this course in English. Okay, so these are the exceptions. The courses that are thought to be chosen as elective courses for the bachelor, or this special course. The others will be in English. This gives me the opportunity to talk about an important thing that is which is the road that you should follow if you consider, among your possibilities for the future, also to teach in secondary schools. As you probably know, almost every other year, the law is changing about this. So the last path is called PF60. Okay, there are 60 CFUs that one has to acquire this. Instead of telling you something that is wrong, I prefer to give you the reference for the person that really knows things, that is Professor Samuele Straulino, and he's also the teacher of the Didattica della Fisica course. You will find Professor Straulino in room 11 after the break, if you want to, or you may contact him in another moment. And what can you do afterwards? Obviously, just an idea, because this is something we could talk about for a long time. But essentially, what you can do if you want to, to go on studying and start an academic career, you have to take a PhD in Italy or abroad, and that this will open you the possibility of an academic career in the universities of research institutes. Otherwise, there are many other possibilities which you can access even without a PhD, but even with, if you want. It's not something that, you can take your graduate studies and then decide that you want to go to a high-tech company, and it is perfectly fine, okay, or to teach in schools. But it's not strictly required for doing these things, while it is for the other part. For this, we have Professor Poli, that is there. He can tell you about all the many opportunities we have for your future. So you have to discuss with him. Yes. I think I can leave the floor to Michele, who is going to present. You want to say something, Italiano? No.
No, let's say, okay, clearly we are in a transition phase. Okay.
Can you go there so that
yes,
you remain?
We are aware that this is a kind of transition phase. So let's say what will happen exactly will depends a bit on the situation. So I can imagine that if in a course there are only Italian students and the Italian students are all agrees to have the course in Italian, most probably the course can be given in Italian. This is not the situation, I hope, because I hope there will be students, foreign students, and I think that would be a plus for everybody. And clearly, in that case, everything would be in English, okay? So the idea is, but even if one Italian student say, well, I'm here because I like to have the lessons in English and I want to have the lesson in English, I mean, for sure the lesson would be in English. Okay, so that's to be clear. For the exams, I mean, if the lesson were taken in English, I think it would be easier for everyone to give the exam in English. I don't think you have to be scared about that. Okay?
Yeah, think about this as an opportunity, actually. It's something that will be helping you, right? So, as Professor Casetti said, I'm going to give you a very short overview of the 6 curricula that we have. This is only think about this presentation as the index of a book, and then you will be reading the book in the parallel sessions, right? Entering all the rooms and then asking questions. I strongly suggest you to ask questions and go to the whole room and see, what's happening for the whole curricula. So I'm gonna go very quick and only talk about keywords, basically, to help you brainstorming ideas. And first of all, I want to see that I'm happy to see you here, many faces that I can recognize. I'm very proud of you guys that you make through the process and you're here. So let's start with the theoretical physics, which is one of the possible curriculum. And what are the main subjects of this curriculum? Well, you will be studying courses dealing with physics at microscopic scales, so quantum field theory and elementary particles. Also, courses dealing with physics at large scales. So we're talking about theory of general relativity here and cosmology, right? And also things which are a bit hybrid in the sense that they are between theoretical physics and mathematical physics, right? And this pretty much mirrors the research activities which are conducted, which are carried out by theoretical physicists at the department and the nearby institutes. So indeed, researchers here work on things regarding the standard model of elementary particles. So we're talking about new physics and collider experiments, also cosmology and astroparticle, but also quantum gravity and string theory. So keep in mind these topics. And also statistical physics, or quantum fields and application of these theories, as well as relativistic matter and physics at very high temperature and high density. And also mathematical physics, right? So these are the line of research that you can be working on if you do theoretical physics and you decide to carry out a thesis with a professor in this curriculum. And then we have a curriculum in nuclear and subnuclear physics. All right. So if you choose this curriculum, you will be taking courses regarding nuclear reaction physics. So what is happening in nuclear reaction physics, and then particle physics at accelerators, like the Large Hadron Collider, detectors for nuclear physics. So this is more instrumental, like, instrumentation-driven courses, and also astroparticle physics and gravitational waves, which is really hot at the moment. Again, the courses in this curriculum are aligned with the research activity carried out at the department and the nearby institutes, and in particular, dynamics of nuclear reactions and the equation of state of nuclear matter, or structure and deformation of nuclear matter studied through spectroscopy technique, as well as development of state-of-the-art nuclear instrumentation and techniques for fundamental physics and medical application. And also, the nuclear people, they are social and they have an Instagram page, so feel free to follow their page on Instagram. There are 2 macro areas, more or less, so particle physics at accelerators, UNIFI, and also cosmic rays, neutrinos, gravitational waves. So, feel free to explore more, ask questions about this during the parallel session, scan the QR code. Just want to mention that both these macro areas, they have plenty of opportunity to, follow up with collaboration and travel opportunity to several institutes and laboratories around the world. Also collaborating with international space agencies in the case of astroparticle, neutrinos, and gravitational waves. Another curriculum that we have is physics of matter, right? Fancy slide. We also have a fancy slogan here: from single atoms to advanced material and living systems. It's all about matter and light. So you'll be studying atoms, of course, light, condensed matter. We'll be taking courses on quantum science and technology. So, all the theory behind quantum information, quantum computing, quantum sensing, and quantum simulation. You will be studying courses dealing with sounds and technology of light, and also physics of living systems. Again, the courses, they mirror the research activity, and the research activities are carried out in almost 50 labs in the area, right? So the department plus LENS, CNR, INRIM, INFN, and all these institutes that work on these things, and you can actually collaborate with scientists in this department as in these labs, and you can actually do the full immersion experience into these academic groups already starting from your thesis. And also there are plenty of career opportunities like PhD available not only in physics but also atomic and molecular photonics and quantum technologies, right? Astrophysics, I'll do my best to try to not be biased towards this curriculum, as I am an astrophysicist. Again, fancy slogan: from the tiniest particle in plasmas to planets, stars, galaxies, and cosmology. Explore the vastness of the universe through multi-wavelength observations with the most powerful telescopes, advanced instrumentation, and theoretical models. We have 3 different possible paths. One is theoretical astrophysics, the other one is observational astrophysics, and also then we have a path for experimental and technological astrophysics. As for the other curricula, the courses, they are aligned with research activities, and indeed, between the department and the observatory at INAF, in Arcetri, we have activities ranging a broad range of hot, modern topic. And we have high energy astrophysics, solar physics, so, astrophysical plasma, galaxies, black holes, and cosmology, as well as exoplanets and astrobiology. And these are all phased both via a theoretical and observational approach. And also we have ongoing line of research in telescopes and instrumentation. You will have the possibility of taking part in major international research projects and collaborations. I'm reporting here a few modern, powerful telescopes and big cosmological and galaxy simulation, and also have the possibility of feeling the telescope vibes, so traveling around the world and see these beautiful machines in beautiful places. Also, we have a curriculum, Physics of Complex System, interdisciplinary theoretical computational training in the physics of complex systems with application in various fields of physics, biology, engineering, computer science, cognitive and social sciences, medicine, economics. So this is a curriculum that is for you guys if you have interests overlapping all these areas. Breakdown of the study plan. Well, you will be doing courses on theoretical physics of living system, computational physics laboratory, statistical mechanics, non-equilibrium and stochastic processes, as well as dynamical systems and theory of chaos and theory of complex systems. And again, this is in line with research activities carried out here and the nearby institutes on complex networks, signal transduction and error control in biology, transport phenomena at the nanoscale level, non-equilibrium statistical physics and life's origins, as well as simulations of complex biomolecular systems, ordering and patterns, and also machine learning and artificial intelligence and their application in physics. Spoiler alert, we also have a new new course on this starting from the next year. Last but not least, we also have a curriculum on applied physics. So this is like pretty much putting together a bit of everything, but aiming to provide skills in the applied technological and didactic fields. Done in parallel with other centers and labs like INFN, CNR, LENS, and also the LabEC, which is just here down the street, and the Department of Experimental and Clinical Biomedical. You will be following courses on medical physics, physics for the environment and cultural heritage, large volume muon radiography, developments of materials for energy efficiency, optics and optometry, which follows up the Laurea Triennale in optics and optometry, and then physics education. Again, what are the main research line of research in here? We have environmental and cultural heritage, muon radiography, and medical physics. So this hybrid field where you apply the, your physics background to the advancement in medicine and medical imaging, radiotherapy, nuclear medicine, radiology, and so on. Also development of material for energy efficiency, optics and optometry, as I mentioned, and the physics for teaching if you, aim to become a professor at high school level. All right, I finished, but before we guys leave you for the parallel sessions where we strongly invite you to talk with people, I want to leave you with a few final recommendations, and I'm taking this very seriously. So today is your day, all right? Everything is meant here for you. So dive in with curiosity and explore all the amazing possibilities which are waiting for you. You're feeling the pressure of the choice, that's totally normal. Just breathe, smile, and remember that this is part of the adventure. Just enjoy the moment. Also, please don't be shy to ask questions. We are here for you. Ask challenging questions, difficult questions. We love that. Chat with students, researchers, and professors during the parallel sessions, and you will have a beer. So this, helps in making conversation more relaxed. And try to make this day unforgettable. It's an important day. All right, you are deciding for your future, so this is important. Just make sure that one day you look back and smile knowing it was part of something awesome. I leave you here with the QR code for the master's degree. If you want information on the program, you can write Lapo, me, or Vitaliano Ciulli, Professor Ciulli, who is the president of the program. And this is the roadmap for the parallel sessions. Please make sure that you go in all of them, you talk with people, all right, take a picture indeed, that's a good idea. Applied physics is room 11, astrophysics room 15, complex system room 17, and in complex system you can also talk with Professor Piazza on the Erasmus stuff related. Nuclear particle physics is room 18, physics of matter room 36, and theoretical physics room 38. And we have School of Sciences info point and the library info point all the way right in the corridor. And with that, I thank you guys for being here.